Okay, great. Are this talk being recorded?
Yes.
It is? Okay, awesome. Okay, great. I guess I'll go ahead and get started. So, while this talk is specifically talking about this approach from Eigenlayer, I do believe, and I think a lot of people agree with this, that this technique and this approach is actually going to be adopted elsewhere. You're seeing this approach adopted on Bitcoin, Ton Network, Berachain, Monad, basically every L1 that I think it will exist with a non-significant amount of, I would say, FDV. I believe this approach will be picked up across the board, and Eigenlayer just so happens to be one of the first examples of this, as well as the innovator in this space. So while this talk again is specifically, I'm talking about it from the perspective that I have working with Eigenlabs and Eigenlayer. I think this is more of a philosophical, general idea that we're starting to see proliferate. When you think about developer platforms, you might not consider things that I consider a developer platform, which I'm going to dive into in just a moment. But when you understand some of these, I would say, new paradigms almost, and I hate to use the word paradigm because it's often, people use that almost in an outlandish way, when in reality, it's nothing that significant. I do think that there is something significant for the platforms that I'm going to be talking about in just a moment. But when a new developer platform comes to existence, it unleashes innovation in ways that we don't really know how to predict until they become in existence. Example, cloud. Cloud is a developer platform that enables 10x, 100x developer velocity for building out software, but also for scaling software. So when you come to the realization that you want to build a piece of software, you want to build an application in the traditional web space, you do not go to Best Buy or the internet and buy a server, have it shipped to your house, and you do not build it on that server for the most part. You typically use some type of infrastructure that has already been spun up somewhere. This could be Hetzner, could be AWS, it could be different variations of this, but essentially people are now utilizing existing infrastructure that exists as opposed to building it from scratch. These are different, I would say, forms of abstraction that are in this similar category. But probably the one that is used the most right now is some form of cloud infrastructure like AWS, GCP, or Azure. And at the very core, you have some type of server. This could be something, again, like a DigitalOcean droplet, or it could be an EC2 instance. And from there, you're able to abstract away and not have to deal with managing that infrastructure yourself from scratch. You go and you build your software there, and AWS deals with all of the what we used to call undifferentiated heavy lifting. Let's say you want to have your application be delivered all around the world, very near to the user. You can spin up something like a CloudFront distribution, and then you have all these other services and features that you can implement really easily using some type of software as a service on AWS, or just utilizing a high performance, high throughput database like RDS or DynamoDB. But really, the whole point of this is like with AWS, you don't have to go and build out this CloudFront distribution. You don't have to go and manage your server. You don't have to go and manage your database. All these things are kind of there for you, and you can focus on your core product or service. So this developer platform, cloud, has really allowed a lot of companies and teams and really just industries innovate over the last couple of decades, last 10 or 15 years, you could say. So really what talk is about is around building these sorts of developer platforms, but focused on Web3 and decentralized verifiable services. So when we think about building out decentralized infrastructure, you have a main challenge in addition to just building out the product or service itself, you also have to bootstrap your economic security for that service. So when you're building an application in a smart contract in a dApp, you're inheriting the underlying security for that Solana application or for that Ethereum application or for that base app. But if you want to build something outside of that service, let's say you want to build a specialized Oracle or a specialized AI, verifiable AI processor or some type of coprocessor or anything that doesn't fit within the constraints of the EVM, you are on your own or you're having to utilize something that exists already. You cannot go and say, oh, I'm going to go ahead and build out my new decentralized network for this individual feature that I want. Because if you did do that, you now have to build out this entire network from the ground up, which often means launching a token, getting people to buy and use that token to run validators and secure your network. This is a massive undertaking. So what you typically see are people constrained within the virtual machine that they're building, along with whatever services are available from that ecosystem. For example, you might utilize something like Chainlink for your Oracle or things like that. But if they don't exist, you can't build the thing that you want. So with that taking into consideration, let's look at how we might solve this problem. And by doing so, we're going to go back a step and look at the evolution of blockchain networks. At the very beginning, the first blockchain was an application-specific blockchain. And Bitcoin is very good at doing two things. One, it offers you the ability to say, okay, there are only going to be X amount of Bitcoin ever. There's never going to be any more than that. That's a commitment that this network offers to the user. The second commitment that it offers to the user is that you can actually own and transfer your own Bitcoin, and you can make these different transfers, and no one can really take that away from you. Other than that, it doesn't really do anything. You can't say, oh, I'm going to go build my application on Bitcoin by deploying an application to Bitcoin. It's an application-specific blockchain. It's very coupled. You have all of these different pieces, the consensus, and everything is all coupled together into a single application, which is Bitcoin. So if you wanted to build your own blockchain application before Ethereum existed, you either had to fork Bitcoin and make some modifications, or build another blockchain from the ground up. So we had Bitcoin, we had Litecoin, we had Namecoin. All of these were slightly different in their own way. The next evolution was the ability to have a smart contract blockchain. So Ethereum was the first smart contract blockchain. And this was really the first developer platform for building blockchain applications, because you could now say, okay, we have this underlying pool of security, which is ETH, and we can now build applications and inherit that security without having to bootstrap that security from the ground up, right? We're just able to write our code, deploy it to the network. We can literally fork someone else's contract, change one line of code and deploy it, and we're now inheriting the security. So we're kind of abstracting away having to build all of that from the ground up, and we're now able to write our applications. This unleashed really what Web3 is today. So we went from having to build your own blockchain from the ground up to being able to utilize the underlying consensus, security, and execution and just build our application. What came next? Well, we're going to dive into the roll-up, I would say, roadmap of Ethereum. But this placed Ethereum, in my opinion, and Solana and all these blockchains on the same level as some of the more well-known developer platforms that existed before then. Examples, the App Store. The App Store, though, isn't just the App Store. The App Store is the App Store, it's Xcode, it's Objective-C, it's Swift. It's all of these tools put together that enable developers to build applications and launch software, in this case, mobile applications, with a lot of guardrails. You can't just do whatever you want. You have to abide by certain constraints, a lot of constraints. But when you do that, you're able to actually have distribution. You're able to have a programming language. You're able to have all these things that enable developers to build whatever they want. Everything from Uber to a fart app, whatever you want. Like, people were doing all kinds of stuff. This was really cool. It wasn't possible before. Another developer platform that we already talked about was AWS, but people are building developer platforms on top of developer platforms. So you've probably used something like Vercel, which is a developer platform for building, deploying, and maintaining and having CI and CD for web applications and now web services. Vercel is built on top of AWS. You have things like Cloudflare as well. These are essentially services that enable developers to scale and build web applications. And then with the invention of smart contract blockchains, we now have developer platforms for building out decentralized applications. I have Ethereum, Base, and Solana listed here. So beyond that, we started realizing that you cannot scale blockchain applications only vertically. You now have to actually realize that we are trying to compete with databases like DynamoDB that can manage, in the case of Amazon.com and Prime Day, they were able to manage over or around 100 million operations per second for a single application. And the interesting thing to underscore there is that this application was not sharing their infrastructure with every other application and every other user on that network like we do in the blockchain world. So what I mean by that is when you build something on Solana, you're sharing that block space, you're sharing that blockchain with every application that's ever been deployed on Solana and every user of that application. So we are using a shared network. No matter how performant Solana becomes, or Base, or Mega ETH, or any of these blockchains, you're essentially having this shared network. So therefore, we've now kind of seen the whole app chain thesis come out of that, where developers and teams have realized, okay, if I want to really maybe potentially scale in the long run, I do want to have the highest throughput and the lowest latency and the lowest cost at the VM and at the actual execution layer. But I also might want to have my own block space and have my own blockchain for my application. I don't want to share this block space with other people. So you have now this roll-up roadmap where developers and teams are starting to build their own roll-ups. So you have Uniswap announced their own roll-up. You have all of these different teams like Aave and all of this talking about building their own blockchains because they want to have their own blockchain for whatever reason. Some of these are app chains, some of them are not. We won't go into that. But the general idea is like we're scaling both now horizontally as well as vertically. We want to make execution as fast as possible, but we also want to like expand that block space. So this is interesting because we're now adding a new paradigm to the evolution, because rollups allow anyone to build a new execution environment on top of this common consensus layer. So we now have evolved from being able to deploy your own application to being able to deploy your own execution. But we're sharing this underlying consensus and security. This is interesting, but the supporting infrastructure is, for rollups allow anyone to build new execution environments on top of the common consensus layer, but the supporting infrastructure is unable to inherit that security. What does that actually mean? Well, it means that you can build rollups, you can build dApps, you can build those two types of products on top of Ethereum security. But if you want to build an Oracle, if you want to build a coprocessor, if you want to build a decentralized sequencer, if you want to build a ZK verification layer, if you want to build anything that isn't one of those two things, you cannot inherit that Ethereum security. So what do you see? Well, you see people launching new networks. You see a Chainlink competitor come and say, we're going to build the next Oracle, and they're going to now launch a token, and they're going to bootstrap validators. That's a ton of work. So the general idea is that how do we solve this problem of validating a new service? When you want to have a new service that doesn't fit into either a rollup or a dApp, you have to bootstrap this validation. You have to launch a token. You have to get people to participate in this whole network. Stakers, operators, which in our case are validators. So the question that EigenLayer and shared security and restaking attempts to answer is this question. What if developers could build arbitrary applications in the programming language of their choice, but inherit the same security as a smart contract blockchain? Meaning, what if I could build anything I wanted to in Rust, JavaScript, Go, but I could inherit that underlying security of Ethereum, I would say Solana, whatever underlying security that we would like. And that's the general idea around shared security, restaking, and in this case, EigenLayer. You can deploy any type of arbitrary decentralized infrastructure without having to bootstrap that new trust network. You can just inherit the underlying network. So now we're evolving beyond the application specific to the inheriting the Ethereum security for building within a smart contract to rollups, and now we're able to build just basically anything. So this new developer platform allows you to build arbitrary services. We're starting to see all of the different things that we typically have seen built from the ground up now being built on EigenLayer. So anything you can kind of consider. Again, I kind of talked about oracles and coprocessors. We're starting to see a lot of verifiable AI. So we have around 25 different teams building AI-related products there. So when people think about EigenLayer, they often are talking about restaking. They're often talking about, I would say, the shared security. But this is only kind of like a means to an end. The staking and all of that stuff is the means to what I would explain EigenLayer is as a platform that enables developers to launch arbitrary decentralized networks faster and more efficiently by inheriting Ethereum security. And now we're beyond just Ethereum security. We're also allowing arbitrary tokens to be staked and restaked. So there are 4 different network participants for the most part within EigenLayer. You have the stakers, who provide the economic security. You have the operators who run the AVS software for the AVS developers. AVS is an acronym for Actively Validated Service. This is basically just any arbitrary network. And then you have the app developers that build for the consumers. We've tried to put together this map of the different categories that we're starting to see being built. Data availability is the core product that we started to validate the fact that you can actually build in this manner. So EigenDA is a data availability layer. It was launched in April on mainnet. And EigenDA at the current moment has the most economic security, the lowest cost, and the highest throughput of any data availability layer. And it was built with a fraction of the number of developers of alternate data availability layers that are on the market today. So this validated the idea that you can not only build in this manner, but you can actually build more efficiently, and you can build a higher performance, higher quality product in a shorter amount of time. Other categories, so we have these categories at the top, and then we have subcategories. Roll-up services, but in reality, you could consider everything kind of a roll-up service. But core roll-up services might be bridges and sequencers and things like that. We're seeing tons of coprocessor use cases, most of them being around AI and ZK. We're also seeing crypto economic coprocessors as well. The things that I'm more interested in, though, to be honest, are essentially higher quality versions of products that already have product market fit. Storage, long-term storage, permanent storage, those sorts of things, and databases. And I would say indexing layers. Because with this model, you can build more rapidly, and you also don't have to worry about latency because it's optimistic. So when Shriram first pitched this idea, he had all of these different categories listed. And now, I would say since February that I've joined, we've now seen pretty much all these categories filled out with real products with literally tens of billions of dollars in value across all of them. So we have Espresso building decentralized sequencers. We have Hyperlane building bridges. We have Opacity Network building ZK-TLS. We have Lagrange and a handful of others building in the ZK coprocessor space. Pretty much anything you can think of, people are building. Right now, we're tracking about 500 teams or so building AVSs. I would categorize about 25% of those as real protocols that are actually going to raise money and be able to go to market mainnet with a fair amount of certainty. This is kind of outdated. When this was put up, we had 18 on mainnet, 40 on testnet. I think we have around 70 something in testnet. Around, I would say, about 125, 150 that we consider in dev that we take seriously. Around 500 or so that we're total tracking. Some of the developer tooling that's available right now, we maintain a core Rust and Go SDK. There's also a TypeScript SDK that's available. Authentic is a product that allows you to go to market with ADSs a lot faster. Not only do they offer a product, but they also offer support and a team. And I think Authentic here gave a presentation earlier. We're tracking around, at this point, 50 or so reference architectures that are available on our websites, on our documentation that we have in just a spreadsheet. And I think that I lost my presentation there. It's fine because this is pretty much over. Okay, there we go. And then our team is also working on a handful of official reference architectures that are coming from Eigenlabs. And then the reason we're building these reference architectures is because we want to show like a fully fleshed out end-to-end product that has slashing and everything built in. And those are not ready yet, but it's something that we're working on. If you want to see what's available right now, you can go to eigenlayer.xyz/ecosystem. And that's it. Thank you.